Okay, for 7-19, we're just going to continue with a little bit of review of things that we have learned. It says to determine the values of x and y in this diagram. So it's a 30, 60, 90 triangle, and yes, I do want you to draw the triangle. Let's see. Whoops. Okay, we've got a leg that is 6, and that is my short leg because it's across from the 30-degree angle. So remember that your hypotenuse is double your short leg. So then y would be 12, and your long leg is your short leg times the square root of 3. So your long leg would just be 6 square root of 3. There you go. That's it. For 7-20, change each expression into radical form and then give the value. Okay, so let's write these down. So we did this last week, and I know it can be a little bit hard to remember how this all works. So if you get stuck, just go back to a problem that's easy. 4 to the 1/2 is 2. 9 to the 1/2 is 3. That exponent of 1/2 is the same as taking the square root of 4. So square root of 9 and so on. So that is your root. The number on the bottom is the root. The number on the top is how many of those repeated factors you want. So if it's 125 to the 2/3, that's the same as writing 125 to the 1/3 squared. And I'm doing this because sometimes it helps you to understand it a little bit more. So then I'm looking for a number that when I multiply it by itself 3 times, I get 125, because this is a 3. That's how many repeated factors you want. So 5 times 5 times 5 is 125. How many of those do I want? I only want 2 of them, because this is 5, so I'm doing 5 squared, which would be 25. Now, could you put this into Desmos and get it? Yes, you could. And there's nothing wrong with that, except that you really should use technology to support your learning and not replace it. So I recommend that you keep practicing until you can do it without the calculator. Okay, B. 16 to the 1/2 is asking for what number times itself. I want 2 repeated factors, and when I multiply them I get 16. Well, that's going to be 4. That is just the square root of 16. Okay, C, we have 16 to the negative 1/2. So remember, did it say negative 1/2 or negative 2? Negative 1/2. Okay, that is just shorthand for saying that this base and this exponent are in the denominator. So this is just 1 over 16 to the 1/2, and we already know that 16 to the 1/2 is 4, so this would just be 1/4. That negative exponent doesn't have anything to do with anything being negative. Okay, and then part D, we have 1 over 81 to the 1/4, to the positive 1. So that's saying what number can I multiply by itself 4 times and I get 1 over 81. Now you may not know that off the top of your head, but you could just guess. You could try 2. 2 times 2 is 4. 4 times 2 would be 8. 8 times 2 would be 16. So that's too small. Let's try 3. 3 times 3 is 9. 9 times 3 would be 27. 27 times 3 is 81. So I'm saying 3, but really it's 1/3, because 1 times 1 times 1 times 1 is just 1. 3 times, or you can think of it this way, 3 times 3 is 9. So this is 9, this is 9. 9 times 9 is 81. So the fourth root, 1 over 81 to the 1/4 power, is 1/3. My answer here is 1/3. Okay. We haven't reviewed exponential equations at all this year, and I think in light of what we are dealing with, it would not be a bad idea. Whoops. Okay. For 721, the principal's new car cost $35,000, but in 3 years, it will only be worth $21,494. Write an equation for this situation and explain what each part of the equation represents in the context of the problem. What is the annual rate of depreciation? So when you see something like this, you may not be sure, is this a linear equation? Is it exponential? But when you see something like this, depreciation, that means it's decreasing by a percentage. It's not decreasing by the same amount each year. It is decreasing by a percentage of that value of that year. So let's set this up. We know it's going to be exponential. And if it's an exponential equation, it's going to be in the form a b to the x. This is your starting value. And this is your multiplier. So with linear equations, you had y equals mx plus b, and you had different versions of a linear equation. With exponential, you have y equals a b to the x, and that's the most common way that it's written. So hopefully we will start to see an exponential decrease in the number of cases of COVID as time goes by. We've certainly seen the growth. Here we have a starting value of 35,000. So let's plug that in for A. Let me come down here. And we don't know what it's decreasing by. So I'm just going to put B for the multiplier. And that would actually, let's take this. Oh yeah, that's right. Sorry. I'm getting sidetracked. Okay, so 35,000 times b to the third power. This is my independent variable, which is usually time, and this is my dependent, which is the value of whatever I'm talking about. So 35,000 times b to the third is equal to 21,494. After 3 years, the value is down to this amount. So we have an equation with one variable. One variable means one solution. So I'm going to solve for b by going backwards. I'm going to divide both sides by 35,000. And that's going to give me b to the third equals whatever that is. And I'm actually not going to write that down. I'm going to just bring down this fraction because I know the next step is going to be to undo the cubing by taking the cube root. So I'm going to take the cube root of, and you could do this on Desmos. I'm just going to do it on here. So the cube root of 21,494 divided by 35,000 is, I'm going to round that off to 0.85. So my multiplier is 0.85, and that just means, so then my equation, let's come up here and write the equation. Y equals 35,000 times 0.85 to the x. That means that 85% of the value remains each year. If you did a table, let's look at the table real quick for this. Okay, and to get the table, you just click on that little settings wheel and then you get your table. Okay, now I'm really not interested in negative values here because I'm talking about time. So here's the year that it was purchased. It was worth $35,000. If you were to divide, 0.85 comes from dividing the new by the old. So 29,750 divided by 35,000 would give me 0.85. Or multiplying 35,000 times 0.85 would give me 29,750. And that takes a while to kind of make sense of, but the more you practice, that's why we're going back in and doing a little review. The more you practice, at some point, you may not get it right away. At some point, it's going to click. It's going to start to make sense. Okay, I think that's all we're going to do for this assignment. Oh, that's only 11 minutes. Well, okay, you're welcome. I know that Wednesday was kind of long, so I'll just let you have a short video for today.